How can we know how temperatures on Earth have changed over time? This is a very important question if we want to understand the truth about climate change. To answer this, and get an understanding of where temperature data comes from, we have to look briefly at the history of temperature measurements and how the modern system of measurements evolved. In the early 1600s, Galileo and other scientists experimented with a variety of devices to measure temperature. Over time, this technology evolved to become more and more accurate. In 1709, Daniel Gabriel Fahrenheit invented one of the first practical thermometers. It used alcohol in a sealed glass tube. As the temperature increases, the liquid inside the tube expands, allowing for the temperature to be measured. A few years later, he began making thermometers using mercury, which provided more consistent measurements. Fahrenheit created his thermometers along with a standardized scale for temperature measurement. Because of this, it became possible to make precise, standardized measurements of temperature. Mercury thermometers came to be widely used. They would remain the standard for temperature measurements into the 21st century. The invention of precise thermometers, along with a standardized scale, allowed for the creation of precise temperature records. During the 1700s, at a number of locations, people began using thermometers to make regular temperature measurements. By the late 1700s, temperature measurements, as well as measurements of other weather conditions, were being taken regularly at sites throughout Europe. Eventually, there were efforts to establish international cooperation around the collection of weather measurements. In 1853, the first International Meteorological Conference was held. This conference brought countries together to adopt standardized methods for ocean measurements taken by ships and to get them to agree to share their records. Storms at sea could be deadly, and nations thought that by working together and sharing information, they could reduce the risk to their ships. International cooperation took another step forward in 1873 when plans were made to establish the International Meteorological Organization. The invention of the telegraph had created the possibility for true weather forecasting. Information about an incoming storm could be passed on to people a long distance away in order to warn them before it arrived. This required cooperation and the sharing of weather data. The International Meteorological Organization served to promote this cooperation. It also promoted the adoption of standardized methods for taking measurements. Many countries came to adopt standardized observation times, as well as the use of Stevenson screens that shelter thermometers and make their measurements more stable and accurate. Also around this time, many countries began setting up their own national meteorological offices. The UK established its Met Office in 1854. In the US, the United States Weather Bureau had its origins in a bill passed in 1870. France and Germany also established national weather agencies in the 1870s. Argentina founded its National Meteorological Service in 1872, the first in South America. In Asia, in 1875, the India Meteorological Department was established. In Japan, the first observatories were set up in the 1870s, and they served as the precursors to the Japan Meteorological Agency. These organizations served to expand the collection of weather and temperature measurements and begin the creation of long-term records of weather data around the world. The number of weather observatories continued to increase, and more measurements were collected. The invention of the airplane in 1903 and the onset of air travel added further importance to the collection of weather data. This contributed over the next several decades to even more investment in weather measurement. Following World War II, the World Meteorological Organization was established as a replacement for the International Meteorological Organization. Its main functions were to promote the exchange of data and research, and to promote further standardization of weather measurements. It took advantage of modern methods of communication and information exchange and was especially focused on creating a global weather forecasting system. Weather observation sites continued to expand in number over the following years and became increasingly widespread. In the mid-1960s, there were around 8,000 meteorological stations on land and around 4,000 ships in the oceans that were taking measurements. What does all of this data that was collected show us? In the 1970s and 80s, there came to be growing interest in global climate and how global temperature has changed over time. In an effort to recreate a historical global temperature record, researchers began working with long-term temperature records from around the world. One of the first of these modern global temperature analyses was published in 1981. It was conducted by NASA's Goddard Institute for Space Studies. The process for this type of study requires gathering data from the national weather agencies of countries around the world. Researchers have to work out data sharing agreements with these countries, compile all of the data, and then generate estimates of global historical temperatures. Over time, these studies have gradually expanded to include data from more countries and more observation sites. In the 90s, researchers began to incorporate data from temperature measurements taken by ships in the oceans. Several different groups have done this work, producing independent studies that estimate historical global temperatures. To see what these studies show, we will start by looking at the dataset known as GISTEMP version 4, which is the one produced by NASA. It is made up of measurements from over 12,000 stations worldwide and extends back to 1880. It has wide geographic coverage, drawing data from stations spread out across the globe. The record from this data shows that global temperatures have increased since the 1800s and have especially increased over the past 40 years. The hottest year on record was 2024, which was about 1.28 degrees Celsius warmer than the average temperature of the 1950s, 60s, and 70s. Next, we will look at the Hadcrut 5 dataset, which is put together in the UK by the Met Office Hadley Centre and the Climate Research Unit of the University of East Anglia. This dataset uses data from around 8,000 weather stations and extends back as far as 1850. The Hadcrut data shows largely the same picture. Temperatures fluctuated in the early years of measurements and then started to increase rapidly in the second half of the 1900s. One of the most interesting and important temperature record projects is also one that started much later than the others. This project, known as Berkeley Earth, began in 2010. It was founded as an independent nonprofit organization and was created by a group of individuals who are concerned that climate scientists might be incorrectly analyzing the data and making flawed predictions. These skeptics set out to independently collect and analyze temperature records to determine the reality of climate change. They received funding from a variety of charities and foundations, including from the foundation of oil billionaire Charles Koch, who had a long history of funding opposition to climate policy. Richard Mueller was brought in to lead the project. He was a physicist with a strong background in scientific research and data analysis, but also a climate change skeptic. The idea for the project was to collect the raw temperature data from around the world and then analyze it while accounting for any potential problems with the data. The 5 main concerns that global warming skeptics had identified were problems with data selection and data adjustment, poor station quality, the urban heat island effect, and over-reliance on complex climate models. The Berkeley project sought to carefully account for each of these concerns. The project was also very committed to making sure that all of their work was done in a way that was fully transparent and open source. They published all of their data and methodologies. The result of this study was that it confirmed that the Earth was warming. Data from the Berkeley project was strongly in agreement with the results of the other global climate records. It showed the same trend of rapidly increasing temperatures especially since the 1960s. If there was ever a moment where the idea of global warming would be discredited, this was it. But when these independent scientists came together to look at the data for themselves, they could only conclude that the Earth was in fact warming. A number of other temperature datasets have also been compiled. These include ERA 5, which is produced by the European Union, CMST, which is produced by China, and a dataset produced by the Japan Meteorological Agency. All of these various analyses show strong agreement on the global temperature record and show that temperatures have steadily increased over the past several decades. Beyond these thermometer-based historical temperature records, as a final way of looking at global temperature change, we will look at two other methods that provide information about global temperatures. Both of these are enabled by modern technology and provide very detailed measurements. First, we will look at satellite data. In the late 1990s, NASA began its CERES program to measure and better understand the flow of energy coming into and leaving the Earth. CERES is made up of a network of satellites with instruments for detecting incoming solar radiation and the energy emitted by the Earth. By comparing the amount of energy emitted by the Earth and the amount of incoming energy from the Sun, the Earth's energy balance can be determined. CERES data shows that over the past 2 decades, the Earth has taken in more energy than it has emitted. On top of this, the data indicates that the rate of this accumulation has around doubled from the mid-2000s to the late 2010s. The amount of incoming solar radiation has remained basically stable over this period, which makes it clear that this accumulation of energy is due to changes in the amount of energy leaving the Earth, likely due to changing environmental factors on Earth. Most of this excess energy, around 90%, is absorbed by the oceans. Oceans make up the largest portion of Earth's surface. Because of this, and because of water's absorptive properties, oceans are the largest sites for the storage of heat. This brings us to our next modern source of global temperature data. Beginning in the early 2000s, the Argo program started operating. Argo is made up of around 4,000 drifting floats spread throughout the world's oceans. These floats take measurements of a variety of ocean conditions, including temperature. They are designed to be able to adjust their buoyancy, allowing them to dive to depths of up to 2 kilometers underwater. They take regular temperature measurements from these depths all the way up to the surface. The measurements from these Argo floats have shown an increase in ocean temperatures at every depth that they have measured. The increase was greatest at the surface and smaller at lower depths. The data from these ocean measurements closely matches the data from CERES satellites. Because these are completely independent measurements that show close alignment, they provide a strong signal that the trend they are showing is real. The data we have looked at in this video paints a clear picture of how global temperatures have changed in the modern era. To get a better sense of what this means, though, we need to provide some context. We have to look at historical temperatures stretching further back in time. That is what we will do in the next video in this series.